I'm going to be.
Okay. Ladies and gentlemen, it is my pleasure to present to you Amanda Rico.
Hello everyone. As Perry said, my name is Amanda Rico. Today I'm going to be finishing my journey as a computer science major in the very same room that I started it in, because I had Comp Sci 1 in here. So, my capstone is called Remind Cure, and through this presentation I'm going to let you know exactly what it is. So, this presentation I'm going to describe the problem that I'm solving with my capstone, how I'm approaching the solution, how the solution works, and then I'm going to demonstrate it. So the problem is that people don't take their medicine as prescribed. And the thing about medicine is that medicine is most effective when it's taken consistently. So on one end of the spectrum, you have people who forgot whether or not they took their medicine, so they take it, and it turns out they've overdosed on their medicine and they go into liver failure. On the other end of the spectrum, you have people who forget in the first place to take their medicine, so then they build up a resistance to their medicine, which generally tends to happen with, no, my emails. That's the one notification that wasn't turned off. Okay. On the other end, so people with mental health medicine, that can be an effect of not taking the medicine consistently. Also, if you're on an antibiotic, that leads to antibiotic-resistant bacteria, otherwise known as superbugs. So that's really bad because people in the old days died of disease. We don't want people now to die of disease. Well, as often as they did in the old days. So the goals for any solution to this problem is to help someone remember their medicine, to help someone store information regarding their medicine, to attempt to record compliance with their medicine, and also to make an accessible interface. So there's actually already several solutions out there that don't necessarily involve technology or involve limited technology. So we have the classic weekly medicine containers, but the problem with those is that you have to remember to refill them on a weekly basis. Also, if you have a medicine that you take at noon and a medicine you take at 3, for example, you might not remember which one to take at noon and which one to take at 3, so that can be a little tricky. There's also bottle caps that serve as timers, but the problem with those is that they don't necessarily display the date, and also anyone can use them, and you don't know, like say you have a skeevy roommate. I'm going to mention the skeevy roommate a lot in this presentation. The skeevy roommate takes off the cap of your medicine bottle a few minutes before you go to take your medicine. You see that it was taken like 10 minutes ago, and it's like, oh, I took my medicine today. No. So there's also phone alarms, but the problem with phone alarms is that they go off every time you set them to repeat, so then you might get used to having a phone alarm. It's very repetitive, which that can fade into the background of your mind, and one day you might say, oh, I'm busy right now, I'll take my medicine in 5 minutes. 3 hours later, you haven't taken your medicine. And then there's the plain old keeping your medicine in sight, and that's the same problem as a phone alarm in that it can fade into the background, and also bringing back skeevy roommate, your skeevy roommate knows exactly where your medicine is. I don't know why you have a skeevy roommate, but. So how my solution overcomes these drawbacks is that it does set up alarms, but they repeat automatically. Not only that, but these alarms are triggered only when you forget your medicine, which that makes them meaningful reminders because you're only getting the reminder if you forgot your medicine. So if you don't get a reminder, you can rest easy knowing, I took my medicine. And there's other events that trigger notification as well, such as when you need a refill. It also reminds you of that. And most people keep their phones nearby. So, and also people usually know how to use their phones, so that's a pretty accessible interface. So the approach that I'm taking is RFID, or radio frequency identification, to track medicine, which that's the same technology they use to microchip animals. A microcomputer to process the information, which this microcomputer relays the information to a mobile app, which is how the user interacts with all of the medicine information. And the app also displays an allergy forecast because also a lot of people have allergies, but allergy medicine is usually take it if the pollen's too high. So RFID is widely used, inexpensive, Like I said, they use it to microchip animals. It's also used in track races and to have precise timing on the race. And it's also used in various shipping applications. So here's one of the tags that I used for my project. And so this is just a prototype. In a final solution of the problem, it would be smaller, maybe integrated into the bottle. And also, the scanner detects when tags pass over it. So if you put the scanner in a place where you would normally keep your medicine, and the medicine bottle is tagged, then when you take your medicine out of where you put your medicine, then you're scanning your medicine bottle without even thinking about it. So it's not something that you necessarily have to remember to like run it over a scanner. Then the microcomputer, Raspberry Pi and Arduino combo. It processes sensor data, which not only is the RFID, but there's a light sensor and a fingerprint scanner, which the fingerprint scanner is great to fight against skeevy roommate. Because then only your fingerprint gets you into your medicine, and if someone else takes your medicine, you get a notification saying that someone else took your medicine. And then the light sensor helps save power with the fingerprint scanner, because rather than having the fingerprint scanner run the whole time, it detects when there's light. So this is assuming that you put your medicine in a dark cabinet, and the fingerprint scanner turns on in response to light. The microcomputer also keeps track of time, which is how reminders work, and it communicates with the mobile app. Now to the mobile app, that is how you access and edit the medical information, which under the hood, it requests information from the microcomputer, and it's also what receives alerts when medicine is forgotten. So now that I've explained everything, this big huge chart, I will walk you through it to see how it fits together. So starting at the phone, when you open the mobile app, the first thing it does is it makes a connection with the microcomputer. It sends some information over to make sure the microcomputer knows where to send alerts as to forgetting medicine. So when you're first opening up the app and you want to get information on, say, what medicines you're taking, it sends a request to the computer, and the computer responds with the list of medicines you're taking. Or if you edit the information, it makes that request, and it responds whether or not you successfully did that request. And this is a very typical server-client relationship in that the client, which is the phone, requests the information, and then the server responds with the information. Now, medicine notification is outside of this request and response framework because it's what's called a push notification. So this is different from regular client-server relationship in that it pushes data from the server to the client without the client having requested it. So that's why it's called the push notification. And then you know immediately on the time that you asked it to check whether or not you've taken your medicine, if you've forgotten to take your medicine or not, and that's how that works. And then Arduino, a lot of sensors are hooked up to this, and it's directly wired into the microcomputer. And then one more time back to the phone, the collecting of allergy forecast. That is the same thing as what the app does for the microcomputer. It requests, the API responds to the request. It's just you can't edit because it's a third-party API. So now it's time for that demonstration. So I have the app. So let's look at these medicines. So let's check out the checking times. I actually set it up to check at about 4:35. So that's a little bit too long for you guys to wait, so I'm going to switch that real fast. Okay, so at 4:29, there should be a reminder to take medicine. So I don't have any notifications right now. So let's say you're browsing outside of the app, and we're playing the waiting game.
Does it matter that the phone says it's 3:12?
No, it's on server time. So as long as the server knows what time it is.
Would time zone change?
Potentially, yes. I haven't tested it in another time zone. Hang on, is it okay if I check the server's time? I'm just gonna quick unplug it. Sorry, guys. Okay, and I'm just gonna change the time again. And I'll just add another one closer to it. Well, I can demonstrate other functionalities. So I'm going to expose the light sensor to light and turn on the fingerprint scanner. And I should have a notification saying that, wow,
Loose wires?
maybe.
I will assure everyone that Amanda's demonstrated this to me many times.
Yes. I think I'm going to try turning it off and turning it back on again.
Okay. So just visually inspect for anything that's loose.
I will turn both the app and the, computer science. It fails when you need it most.
Mm-hmm.
Does the server have a log where you can see if it's actually waking up at the right time?
Okay, nothing appears loose.
Okay, it might be, maybe it does have to be synchronized.
No. Okay, I don't know what that's done. You must know. Okay.
Then I'm gonna do a reset on this.
Okay. It's okay. It's okay. Stay up here with you. Or should I sit down?
You can sit down.
Okay.
I think a reset will help. Okay, the only thing that still needs to restart is the emulator.
It'll still take 15 minutes to start that.
Hopefully not. More like 2.
It'll take a long time to emulate.
Yeah, I think I understand now.
Are there, without disturbing your restart, are there other things we can talk about? Or not?
Well, I mean, I can go on to the next slides of my presentation and try again for a demo at the end. Or, oh, it's starting up again. Okay, cool. So let's try this again. Now so I think it does matter that the phone, I haven't had a sync error like that before. So I think that might be the case. So the fact that I had to change the dates back is a great sign, because that means that the notification was sent. So I'm just going to log myself in with the fingerprint. All right, I got a couple reminders. So I have to take my medicine. And I'm also logged into the cabinet. So I'm just going to quick check which one is ibuprofen. 587. Okay, so first I'm going to take the medicine for the reminder, which I got another notification saying that I need a refill soon because I'm now at 5 pills. Now I'm going to take it a second time before my next remind time, and we should not get a reminder. So my next one was set for 4:36. Yep, 4:36. I'm just going to browse outside of the app, because that's what the average person will be doing when they're waiting for a reminder on their medicine. And look at that, no reminder. So one more feature that I'm going to demonstrate is that it does notify you when skeevy roommate is calling. So I'm using the wrong fingerprint. And oh look, a notification from my medicine. It was not taken with the correct fingerprint, so it wasn't me who took my medicine. All right, now that we got that along. So, goal fulfillment. Other than that little hiccup in the demonstration due to a sync error, I overall hit the target. It does remind you to take your medicine, and it does tell you when you need a refill, if someone else is taking your medicine. I actually had 2 other sensors included in my original write-up of the project, but they weren't actually essential to the key goal of reminding you to take your medicine. One of them was a temperature humidity sensor, which that was just ideal conditions for medicine. The other one was a pulse ox sensor, but that one was one that actually worked on its own. So, and then reflection, I now have a 4th bullet point. So the first one, implementing hardware can be really, really frustrating, because while software, you can usually have a tell on whether or not something's going wrong, hardware, if you hook it up wrong, it might still seem like it's going correctly. But on the flip side, it is extremely satisfying when you get your hardware to work. It was the greatest day of my life when I got my scanner to work. And it was also really cool when I got my light sensor and fingerprint scanner to go together, in that the fingerprint turns on when light turns on, because it's my code on the computer affecting things in the real world. And I think that's really awesome. So I'm hoping to be able to do more hardware projects in the future. I also learned more about how I personally learn new programming languages. Pretty much every programming language that I've learned has had some form of instructor guidance beforehand. I didn't learn to program until I came to Carthage, so my first experience with programming was with some form of instructor guidance. I had to learn a new language for the server side. It was PHP, and I had to do that completely on my own, or at the very least, I did it all on my own. I definitely could have gotten some guidance on that, but I was able to teach myself how to do it, which is great, because that's what computer science is all about, is keeping up with things. So I'm glad I can keep up with things. I also have a better understanding of, like many others have said, I have a better understanding of time management. More importantly, I understand better what an ideal work day, an ideal work week, an ideal work month looks like, and how that would translate into actual work done in those time periods. And finally, for my fourth bullet point that I had to learn during this demonstration is that synchronization bugs are a thing. Beware. But, because, yeah, it would randomly not work before, and I didn't know why, and now I do. And now I can aim to fix that. And that's all I have for my regular slides. Questions?
So you said something about detecting allergies and for the potential allergies. Where was that shown on the application?
So it's actually on the main screen. Let me just actually I can go to it to from the notification. Oh, hey, another reminder. So on the very main page is the allergy information. I got it from AccuWeather's API. So it tells you air quality, mold spores, grass, pollen, ragweed, and tree pollen. And I have it set right now for Kenosha.
So how does that relate to medicine in general?
So a lot of people have allergies, and allergy medicine is usually taken as needed. So you usually need it if it's forecasted to have really bad allergens outside. So if you have that forecast, you can at least have it in front of your face of, oh, hey, I should maybe take my allergy medicine. Yes?
If this were an actual product, how much would it cost the user to get this system into their home?
I'm trying to mentally add up all the costs of the hardware into my head. So I do remember I think it would probably cost over $100. I am not quite sure how much an Arduino Uno costs.
We paid retail, and if it was a product, it would be much cheaper.
Okay, it'd be wholesale.
Yeah.
Okay. Yeah, because the RFID technology, really cheap, like I said, is some of the other stuff might be a bit more expensive. And also having to develop it further to be easily set up. I'm sorry, I saw you before and I didn't call on you, so please.
I remember you said
That's
while you were working on the project that you had temperature and moisture monitors. Did you see this feasibly working on medicine that needs to be refrigerated like insulin or something like that?
Well, it depends on the temperature thresholds of the actual hardware. I'm not quite sure how cold they can go. It's not the best to put a board itself into a refrigerator, but I'm sure if the wire for the scanner was extended, it could probably work if only the scanner was in the fridge. Yeah.
Going back to the demonstration, could we see how adding/removing a medicine works?
Absolutely. So, as you can see, there's not really a button to add a medicine. So how you actually add a medicine is, which actually I just happened to have an extra tag on me, so I was prepared. So I have, okay, cool. So first, gonna get that fingerprint in there. It is I, myself. So you scan it over the RFID scanner. Then when you check your medicines again, a new screen pops up saying, oh, hey, you have a new medicine. So then you just put the medicine in. Do you want me to go through the whole thing? Because it can take a minute.
Sure.
Okay. Ibuprofen's for pain too. So take it twice daily. You only get to select one time to remind yourself, but then you can later, and it automatically interpolates between the next time period, and you can change those later. Expires, let's call it next week. And I only have 10 pills left. And then down here you can see delete medicine button, so if you accidentally, for whatever reason, have some other RFID that's compatible with the scanner and you accidentally put it in there and it's not for a medicine, you can delete it. And it's done, and now it's on here. And then you can edit. No! It's in the database. Well, that's great.
So back to that error, what was it? Was it because that clock in the emulator was not synced to the computer clock?
When I was having trouble getting a reminder? Yes. Now, yeah. So I'd gotten that error once before when I was trying to do a practice demonstration, and the next time that I was trying to figure it out, it worked. So I was very confused. So now I realize that based on how the middleman of Firebase cloud messaging works, it sends it, your phone receives it at the time that it was sent. So if it says that it was sent at 4 something and your phone says it's 3 something, it's not going to get that notification until 4 something.
So it's an emulator thing. It doesn't have anything to do with your implementation.
Yes?
What made you came up with this project? Why isn't it something that you thought of?
So back in the beginning of the year when we were doing, when we were talking about thesis ideas, I texted my sister saying, okay, I had to think of a thesis. What is something really cool in sci-fi you can think of? And her original idea was a medicine bottle that makes really loud noises when you forget to take your medicine. And after some ideas, some evolution, because like one of my first problems with that idea was, what if you forget to take your medicine, you've left, no one's home, and you're in an apartment, and you just get noise complaints because you have this medicine bottle screaming. And I also have a lot of friends who are on various medications, so that also was a factor in it. Like once I thought of it, it's like, once my sister gave me that idea, it's like, that's a really good idea. Mm-hmm.
Very cool idea.
Yeah.
I had a question about security, and that, and privacy, because obviously this is, these are medications, this is prescriptions, this is personal stuff. I'm unclear as to where the data in the Firebase cloud is actually being stored and transmitted.
Okay. Yeah. So how it actually works? So the information, like the only thing that gets passed into Firebase cloud messaging is the name of the medication and what time the notification was sent. The actual information that's passed to the microcomputer is passed through that same client server. So right now it's definitely not very secure because it's a prototype and I just wanted to get it to work. But the same sort of things that would apply to securing your own database would apply to inputting the information and retrieving it.
You could also name it like red bottle, blue bottle.
That too.
Okay, other questions? Excellent, thank you.